In this lesson will teach me to evaluate a piecewise function. Problems 1 and problems 2 were covered in the first video posted on the website. Beginning with problem 3. Use the function written from the story problem on the previous page of your notes. Let's look back. Alright, here's the problem on the previous page of your notes. It says a parking garage charges $5 for each hour or fraction of an hour, up to 8 hours per day. Write a piecewise function to relate the cost, C, in dollars to the amount of time, T, in hours parked. Here's the function written in day 2, lesson 2 of the notes, discussing that the function should be written C of T, that it's a $5 cost anywhere from 0 to 1 hours. It's a $10 cost from 1 to 2 hours, $15 for 2 to 3 hours, so on and so forth. The purpose of today's lesson is to evaluate this function. I've copy and pasted this function from the previous day, and now we need to evaluate it. It says f of 2, or if you like to think about it, c of 2 for cost. So what I want to know is, what is the cost going to be for parking for 2 hours? Looking at our equation, it looks like anywhere from 1 to 2 hours fits in here. Notice that the 2 is in both locations. However, in the first equation, it has the or equal to. So when we park for 2 hours, the cost will be $10 because 2 falls anywhere bigger than 1, but is less than or equal to 2. What is the cost if I park for 6 hours and 10 minutes? If you look back at the problem on the previous page, it says that you get charged for any hour or fraction of an hour. Looking at our equations, for 6 hours, it's going to cost me $35. Anywhere greater than 6 but less than 7. 6 hours and 10 minutes falls within that category. So the cost for 6 hours and 10 minutes is $35. What is the cost then going to be if I park for 3.75 hours? Thinking about in a clock, 0.75 isn't 75 minutes, but 45 minutes. Looking on our equations, 3 3/4 of an hour falls in the $20 range because it's between 3 but less than or equal to 4. So the cost will be $20. The problem doesn't ask for it, but down below is the graph. Notice that it does look like a stair step, referred to as a step function. So when you're thinking about evaluating, you can also look at the graph. So C of 2 falls anywhere from 2 to 3 in here. For letter B, the cost of 6 hours and 10 minutes fell in here. And for letter C, the cost of 3 hours and 45 minutes fell in here. So whether you're looking at the graph or you're looking at the equation, the values are still the same. Last problem for today's video. Graph the following function. I'm going to begin graphing by showing my fences. Because it says that x has to be less than or equal to, or less than 2, or negative 2, I know that at negative 2, there's a fence, a vertical line. I know that between negative 2 and 1 is going to be another one. And that anywhere where x is greater than 1, there is going to be yet a third function. This function has 1, 2, 3 pieces. 1, 2, 3 places to graph. The first equation I'm highlighting in yellow. It says that the function is going to be negative 3 where x is less than 2. Remembering that f of x is the same as y. So this equation is really y equals negative 3. This is a horizontal line through negative 3. 1, 2, 3. But it only lives where x is negative 2 and smaller. Because of this less than symbol, we'll have an open circle. Next equation. It says f of x equals 0. Here, remember f of x is also like y. We can think about it as y equals 0. Don't be tripped up by this one. It is still a horizontal line going through the y-axis at 0. This graph is going to live between -2 and 1. So the y-axis, if this is -1 and this is 1, is 0 here. It's living in this kind of center yard, if you think of it that way. Because of the or equal to, we have a closed circle and a closed circle. The third equation. If we think of f of x equaling 3, it's really the same as saying y equals 3, but this equation is going to happen where x is greater than 0 or greater than 1. So a horizontal line through the y-axis, 1, 2, 3, here. So it's not including 1, but going towards infinity for the domain. This is kind of another stair-step function because they're made up of all of these horizontal lines. Notice that these ones do have arrows pointing towards the negative infinity in the x and the positive infinity in the x. One last note to make. Keep in mind that for something to be determined a function, it has to pass the vertical line test. So if we look at these values, which I'm highlighting in yellow, one of those circles has to be closed and the other one has to be open, because for every one input, we need to have exactly one output. The closed dot represents that for the value of -2, the output is really 0. This open circle just below represents that the equation starts here, but it's not actually including that value. This concludes today's lesson. Please see your teacher with any questions.